Hello guys, so today we are here to solve our daily lead code challenge for the day, and this problem is called as special array 2. Okay, so in this problem we will try to solve uh, and before solving, let's first go through this problem statement, what this problem is actually saying to us. So in this it is given that there is an array. Okay, an array is considered special if every pair of its adjacent elements contain two numbers with different parity. Okay, so parity is about even or oddness. This parity it is being considered here. So, and furthermore it says that you are given an array of integer nums and a 2D integer matrix queries where for queries is equal to from I to 2I. Okay, so ith entry of the queries 2D integer array is the first value is the from and the second is the to. Okay, and our task is to check that the subarray nums from I to 2I is special or not, and when it is special, when every pair of adjacent element contains two numbers with different parity. So one is even, the other is odd. If one is odd, the other is even. If both should not be even, both should not be odd. Okay, and return an array of booleans answer such that answer I is true if nums from I to 2I is special. So the queries are given, and queries is telling which subarray we have to consider, and for that particular subarray, if the answer is correct, we'll be giving that as the correct answer. So let's try to solve this. Okay, and in order to solve this, let's go through this problem statement once more. I'm going to say let's try to start solving this. So in order to solve this, let's uh, create a result array. So this result array will be the same as the length of the queries array. So new int array. So first it makes sense that we have this queries length. So queries dot length, and then we'll put it here. This will give us the result array, and then after this what we will do, that we will uh, we will start a loop. Okay, and this loop will be going from int I is equal to 0, I less than n plus I, and here what we will do, check special. Okay, and here we'll pass nums and then queries of I, and then 0th will be the start and queries of I, 1 will be the end. Okay, like this, and this we will be, the result of this check will be assigning to the result as the ith entry. Okay, and then at the end we'll be returning this result. Okay, like this, and then what we will do, that we will start writing a private private boolean. Okay, and then we'll say check special. Okay, and we will be passing this int array nums, int start, int end, and then what we will do, that from start to the end, so from int I is equal to start plus 1, I less than equal to end plus I. Okay, and we will check if check parity, okay, of nums I minus 1 and nums of I So if it is false, then we will return false, otherwise we will return true. And how are we going to check parity? So private boolean check parity int a int b if a equal to 1, if a and a b and is equal to 1. So it is same. So here we have to return false, and also else if. Again we'll take this and make it 0, this also as 0, then we'll again return false because they are both the same. Else if this is 0, let this be 1, then this is return true, else return true. So if we do it like this, then let's try to run this, see how it's performing. So some error is there. Check special boolean cannot be converted to, my goodness, we have declared this, it should be boolean array. Here also it should be boolean. Okay. Perfect. See, now we'll try to submit this. See, this may look like an correct implementation, but there is this inherent inherent complexity involved, and this complexity is making this to run little slower. And when it is running slower, what's happening, that it is recomputing the same thing. I mean to say, suppose if the queries is such that it's asking for several subsections which are having the same common range, and some range is common, so every time we are performing the same operation over that common range, which is not very a smart way of handling things. And that's because of that it may result in time limit exceeded kind of thing. And let's try to see what is actually happening by submitting this. So as what we were expecting, we are getting time limit exceeded. At the very end, 535th case is not passing, and we are facing this time limit exceeded. And if you see 21 and 9963, 45, 9938, like that it is, so this is a large array and a long, very, major overlap is in between 21 9963 and 45 9938. And because of this overlap in between two different query ranges, we are facing this time limit exceeded. So in this case, it makes sense to convert this problem into a rather perform this check once. And in order to perform this check once, what we are going to do, that we are going to create one, let's take this int m is equal to nums.length, okay, and then we will create one int array prefix sum is equal to new int m, and in this prefix sum of 0 is equal to 0, and then for we will do one for loop for int I is equal to 0, I less than since already 0 has been given the value 1, so what we'll do, I is equal to, and then I less than m, and then plus I we will do, and then prefix sum of I is equal to prefix sum of I minus 1 plus check plus we'll have to, so what we will do that, if the number at that if the number at the ith index is having the same parity as the number at the I minus 1th index, then we are going to if they are having the same parity, then we will be adding 0 here. If they are having a different parity, then we'll be adding 1 here. Okay, so we'll have to modify our this check parity, because right now it's returning boolean check parity, and here we will pass this nums of I minus 1 and nums of I, like this. And then if so, we'll remove the boolean type to an int type, and instead of returning false, we will do 1. So it is false, it will return 0. If whenever it is returning false, we'll return 0, otherwise we'll return 1. Okay, like this check parity. So this will do, and then what we will do, we don't need this actually. Okay, this is the query thing. Okay, so let's so this is the query, we are going over the queries. So let's remove this, and in this what we will do that we will take this start is equal to queries of I, and here it will be 0, and end is equal to queries of I 1, like this, start end, and then what we will do that so valid we can in the result of I, so we have declared the result or not. Yeah, result we have declared, result of I is equal to and minus start, and minus start is equal to prefix sum of start minus prefix sum of end. So this is okay, and we'll finally be returning the result. So this thing is not required anymore in this, we can remove this. So let's run this. So we'll use this test case. Okay, let's first run this. So here what we were doing that we are pre-computing the parity, okay, and storing it in this check parity, and for every number we are doing the same. So 0, okay, so end minus start and minus start queries will be 3 minus 2 1 prefix sum. Wow, it will be end minus start, correct? So we'll remove this. Perfect, perfect. So basically what we are doing here, let me explain what we are doing here. In this we are, pre-computing the, the differences, I mean to say the prefix sum of, and if they are having the same parity then we are adding 0. If they are having different parity then only we are adding 1. So in this way we are able to transform this problem from a simple uh, uh, like brute force checking of each subarrays to a prefix sum pattern problem. And this prefix sum pattern is actually helping us to solve this problem in a very, you know uh, time efficient manner. Because you see, in this test case earlier we were failing, and we use the same test case here, okay, the third test case, and if you are running it, it is clearing. So this is a testimony that by using clever approach of prefix sum we are able to solve this problem. And only thing is, only difference that we are, doing, only different thing what we are doing from the earlier, approach, that we are adding one only if the parity of the current element and the previous element are different. If they are the same, that is, if they both are even or if they both are odd, then we are not adding any number. So it's 0 we are adding, and that is helping us to, convert this problem from a subarray check to a prefix some kind of problem. And this is finally helping us to, compute it in a very efficient manner. So let me submit this. Perfect. So I hope you liked this solution. If there is any doubt, please post it in the comments. With this, I'm thanking you. Thanks one and all. Happy coding. Best wishes.